the founder of Covenant Labs, getting a microphone to talk about blockchain databases. So please join me in welcoming to the stage.
Hi everyone, I'm Jing from Covenant Circle. First of all, I'd like to thank the Link Time for inviting me to the summit. My presentation is about introducing the project of our blockchain database, Covenant Circle. Before I introducing our blockchain database, I'd like to share some work before we started the Covenant Circle. I and my team have done the Thunder Crystal. Before that, I was working at Xunlei. If you haven't heard about this company, it's the largest P2P technology company in China and even in the world. In 2013, I was leading a team to do a Ethereum project named the Thunder Crystal. The difference between Thunder Crystal and the Ethereum project is that this is a crowdsourcing platform which it can connect the idle resource and storage through P2P technology. We connect these idle resources through crowdsourcing and provide these resources for this online streaming video website. In return, the resource provider will receive fiat money. Crowdsourcing makes it easy to get this idle resource. We have tried in some regions that don't have well-developed internet, and we gathered about 20 gigabits bandwidth in 2 weeks. However, if you follow the traditional way to buy the resources, it may take you more than 1 year to get these resources. So this project was launched in 1814 and offered hundreds of gigabits bandwidth for commercial use. Until 1815, there are about 1 million nodes involved in the system and provided about 1,000 gigabits bandwidth and stored more than 1 PB data files. However, the price we reduced the cost significantly. It's about 18% lower than the traditional way to get the resource. It's very critical. When we were doing this project, we had some challenges. The biggest challenge is not about the technology, it's about the pricing. I think there are 2 problems that are worth mentioning here. The first one is who has the right to decide the price. We are the developer and owner of this project, and we pay the crowds and we decide how much we pay. But do we have the right to decide the price? And if not, who has the right to decide the price? And the second problem is how to decide the price. Traditionally, price is set based upon the cost or the competitor product, but both of them have disadvantages. And the price must be adjusted when the cost of the bandwidth goes down as the time passes by. So, a centralized price setter may probably keep the price even if the cost of the bandwidth goes down. So in the centralized world, wealth is distributed unequally, even with the sharing economy. So we think this problem could be solved when we combine blockchain with sharing economy. Blockchain technology makes it possible to replace the top-down hierarchy with a distributed system, bottom-up cooperation, especially when these four conditions are met. So the first is there are a lot of idle resources and devices, and these resources could be connected with and scheduled with a platform. Individuals own the idle resources, and they can join the network without any difficulty. The last condition is blockchain will boost sharing economy with immutable records, and the participator can be motivated by the tokens. So for CDN, data storage, and computing resource, we think it's a perfect example in this case. The contribution of each individual could be quantified, recorded, and therefore compensated correctly. Compared with ride sharing, such as Uber, decentralized pricing is more reasonable because monopoly is eliminated and the pricing right is resolved and returned to the real user. So we think how to improve the current cloud computing. We think the database is a product that fits the four conditions I just mentioned. More than that, we think database could also add value to blockchain. Current public chains are not designed for storing and indexing a large volume of data, and it's very expensive as well. And the reading and writing data on blockchain is not so efficient. So more importantly, public chain doesn't support the structured data and index or searching data on machine. So here is how we designed the blockchain database. We designed this to make storing and indexing faster and easier. The architecture has 3 layers. The circle in the middle is the main chain. We also call it global consensus layer. This layer deals with transactions, anti-cheating, and ledger records. Next is the circle consensus chain. It's on the left and right. This chain processing data replication and keep data consistency and executing the query to from the clients. The last layer is data store layer, which maintains the store engine and provides basic storage and indexing. So here is a framework we developed. Its name is DHRPC. It means DHT plus ECDH and RPC. It's a framework and it improves the safety of the RPC. In terms of calling method, it is compatible with NetRPC in Golang and can replace this library. From the network protocol perspective, the framework analyzes the code, analyzes the data structure, and generate code to make the serialization automatically. So, compared with port buffer, we don't need to write the portal file to define the data structure. But we can still somehow we support user-defined serialization and deserialization. All of this make our development much easier. So here is another protocol we developed. We developed Kayak from scratch. Kayak is protocol similar to the Raft, and we optimize it for the high-latency network environment. Compared with Raft, we improve the protocol for untrusted network, so the system could track the reasons behind the data issues. Finally, we provide two configurable consistency level, eventual consistency and strong consistency. So, talking about the cross-chain application, we now support interaction with Ethereum. As shown in the graph, having a circle will subscribe the wind from the Ethereum, and after handling this request, it can write back the result to the Ethereum, and the DApp can fetch results. So let's make it easy for DApp to read and write messages to the Confident Circle. As you all know, the most difficult part for a complex project is how to ensure the product quality and how to reduce the number of bugs. We make sure the testing coverage for the whole project will not lower than the threshold. Currently, our test coverage is about 76%, and we use some static analytical tools to check the codes. In the Go report card testing, we earned an A+, and we use continuous integration to build the project as well. Besides those regular methods I just mentioned, we also developed some tools to improve the system quality. One of them is GNTE. GNTE means Global Network Topology Emulator, and it is able to simulate network communication, which is very helpful for our developing of the distributed system. You can set the parameters between the nodes and divide the nodes into different regions. And you can configure the parameters between the nodes and the parameters between among the regions. So the current configuration covers all the situations on the network, including latency, packet loss, corruption, duplication, reorder, and bandwidth. Currently, the system is only working on a single machine, so the number of nodes that can be simulated is around hundreds. We are planning to turn the architecture to distributed so that the simulation could be scaled out without any limitation. So this is pretty much about our project. Because of time limits, I can't go into more details. But if you have any insights or ideas, I would like to talk during the break time. And you can contact us through our website and GitHub page. Thank you all for your time.